Yeah, hello students. Today I am going to start a new chapter called matrices. Okay, important part for mathematics. So, in mathematics it have great importance. Not only in mathematics, it's in science. This chapter have great importance. Matrices. Actual importance of matrices is while developing a software, while preparing algorithms. Okay, so the developer will use the concept of matrices. So matrices is important. Actually, we have two parts. One is matrices and another is determinants. So matrices and determinants. So first of all, matrices. After the determinants. Determinant chapter is fully depend upon a special type of matrices called square matrix. Okay, matrix is singular, matrices are plural. First of all, I want define what is the definition of matrix. Here definition is given. A matrix is the rectangular arrangement of mn numbers having m rows and n columns, or matrix is a rectangular array of numbers or functions. The numbers or functions are called elements or the entries of the matrix. Just I will explain through example. For example, 2, 3, 4 given. So write within flower bracket. This is called a set and denoted by capital A. So set means what? Defined collection of distinct object is called a set. After collecting the elements, they are separated by commas and enclosed by flower bracket. This is called a set, denoted by A set, B set, C set, like that. So matrices is also a special type of set, but in general sets we will separate by commas and enclosed by flower brackets, but in this set we will arrange the elements in rows and columns only. For example, 1, 2, 3, 4 elements are given. We want to write in a set form. I can say 1, 2, 3, 4 and close with flower brackets. I can call this set B. But using these 4 elements, you want to create a matrix. So these elements should be arranged in rows and columns. For example, I arranged it like this. So this is called one matrix enclosed by this bracket or square bracket. This is called matrix. So what happened, here also I used 4 rational numbers, but what I did, I arranged in rows and columns. See, this is one row, this second row, 2 rows, and this is one column and second column. I arranged these elements in 2 rows and 2 columns. So such arrangement is called a matrix. So this is I called a matrix, matrix A. So important thing, students, matrix means arrangement of elements in rows and columns, in rows and columns. Okay. So for example, same elements are given. I can write 1, 2, 3, 4. Don't write commas between them. Just I closed the bracket. What is the meaning of this? I arranged these 4 natural numbers in rows and columns only. But how many rows and columns means? I can say this is one row, R1, one row. How many columns? This is one column, this is second column, this is third column, this is fourth column. So by using these 4 natural numbers, I arranged in 2 rows 2 columns manner and 1 row 4 columns manner. Okay, whatever it may be, just arranging the elements in rows and columns. Okay, the resulting arrangement is called a matrix. Matrix is singular, matrices is plural. So generally, after arranging the elements, they closed by small bracket or square bracket. So these two are the notations for matrices. Yeah, now rectangular array of elements. The elements are arranged in rows and columns. The resulting arrangement is called matrix. So what the definition here? Rectangular array of numbers or functions. Why they are called functions? So not only numbers. For example, 1, 2, 3, 4, 5, 6. I arrange R 1, 1 by 2, 7 root 2, 0, 1. I arrange. So what happened? This is one matrix. This is also another matrix. This matrix containing 2 rows R1, R2 and 3 columns C1, C2, C3. This matrix having 3 rows R1, R2, R3, 2 columns C1 and C2. Just arrange numbers. Sometimes you can arrange functions also. Sin x, cos x, 1, 2. This is also called matrix only. This matrix also containing 2 rows and 2 columns. What happened? These are elements actually. These are elements or sometimes entries. Entries are numbers or functions. That's what the second definition. A matrix is an rectangular array of elements or functions. The numbers or functions are called the elements or the entries of the matrix. So these are called elements or entries of the matrix. This matrix contains 2 rows and 2 columns. A matrix is a rectangular arrangement of mn numbers having m rows and n columns. Now, yeah, final notation, observe all of you. For example, a matrix is given, say A, B, C, D, E, F. This matrix contains 2 rows and 3 columns. Okay. So this matrix is to be a matrix having 2 rows and 3 columns. We will write here down 2 by 3. We will write 2 cross 3 only, but you need to write 2 by 3. 2 by 3. A is a 2 by 3 matrix. These 2 stand for the number of rows that containing the matrix A. These 3 stand for how many columns that matrix A contains. So what happened in 2 rows and 3 columns. For example, a matrix is given here like this. Here given 7, 4. What the meaning of this? This matrix contains 7 rows and 4 columns. 7 rows, 1, 2, 3, 4, 5, 6, 7 rows and 4 columns, 1, 2, 3, 4 columns. So these are the elements like that. So what is the meaning of that now onwards? So m by n means m rows and n columns. M into n what nana? Mn. So what is the meaning of that? This matrix contains mn elements. No, here see 3, 4. 3 4s are how much? 12. Sorry, 2 3s are 6. 6 elements are there. That's why if a matrix having m rows and columns, you can say that the entries, number of entries are nothing but m into n. Okay, m into n or mn I can say mn. Or so what you call this? This is called order of the matrix. Order of the matrix. Order of the matrix. Order of the matrix says that matrix containing how many rows and how many columns. Okay. Okay, students. Notation. Okay. Matrix A is given. A11, A12, A13 dot 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 A1 n, A21, A22, A23 so on, A2n so on, AMN 1, AM2, AM3 so on, AMN. Okay, students, observe, this is the general notation of a matrix containing m rows and n columns. M rows and observe here. This is first row, second row, mth row, m rows are there here. So that's why m rows. Columns, no? First column, second column. See 1 here. I will use this. First column, second column, third column, nth column. So n columns are there. First row, okay, second row, mth row. So this matrix containing m rows and n columns. This matrix is said to be a matrix having m rows and n columns. Important. Another words you can say. Another words I will write. So the short notation of this is A equal to, simply they will write small a ij. Okay, m by n. So they will write 1 lesser than I lesser than m r equal to, and 1 lesser than or equal to j lesser than or equal to n. This short notation of the matrix. So what is the meaning of ij means ith row jth column element. This one. This ith row jth column element. Aij is element, not matrix, element. This element is ith row jth column element. For example, A21 given. A2 means second row first column element. See, second row first column element, that one. Second row first column element. A33 given. Third row third column element. Element. A33 means third row third column element. That's why Aij means ith row jth column element, and this is closed by bracket means this is a matrix now. Aij matrix. This matrix containing how many rows or how many columns depend upon I and j's. No, here for example down m by n is given, means this matrix is containing m rows and n columns. What is I means I can be taken from 1 to m. I can be taken from 1 to m. See 1, 2, 3 m, and j can be taken 1 to n. So this is the notation of the matrix important. So already I told that the matrices are great importance in making softwares. So generally in ancient days, why they invented matrices means especially the matrices are invented to solve two linear equations. For example, x plus y plus 3 equal to 0, x minus y plus 4 equal to 0. We have several methods to solve these linear equations. One of the method is matrices method. I think main invention of matrices is solving linear equations with n unknown. That is important. With n unknowns, here 2 unknowns, 2 equations. For example, you want to solve 3 unknowns, we need at least 3 equations. 2x plus y minus z equal to 3, x plus y minus 10z equal to 9. 3 unknowns, 3 equations. So to solve this, easiest method is matrices method. So by using matrices method, we can solve n unknowns, n equations. So but in our present chapter, we can solve a equation with 3 unknowns and 3 equations by using matrices method. This is main intention of invention of matrices. After that chapter is developed, and after that the matrices concept is nowadays you are using in making softwares. Okay. Students, example problem, construct a matrix A with the condition Aij equal to I minus 2j whole square by 2. 3 by 2 matrix given. Okay. So students, observe here, construct a matrix A 3 by 2 with the condition Aij equal to I minus 2j whole square by 2. So I will write Nana A 3 by 2. 3 by 2 means 3 rows and 2 columns. 3 rows. A11, A12, A12. 2 columns, sorry, only 2 columns. Okay. A12, A12. A21, A22, A31, A32. So this is the required matrix. See, 3 rows and 2 columns. Just we want to find A11, A12, A21, A22, A31, A33 according to this notation. So A11 I want to find. Instead of I, you should write 1 Nana. Instead of j, should write 1 whole square by 2, that is equal to 1 by 2. So next what should find Nana? A12 I want. I means 1, j means 2. 1 minus 4 whole square by 2, that is 9 by 2. Okay. Next I want A21. A2 means I is 2, j is 1. 2 minus 2 whole square by 2, directly 0. Next I want A22. A22 I2, J2, that is 2 minus 4 whole square by 2. 2 minus 2 whole square means 4 by 2, 2. Okay students. Next what I want? A31 I want. A31. I is 3, J is 1. So 3 minus 2 whole square by 2, that is equal to 1 by 2. Next A32 I want. I equal to 3, J equal to 2. 3 minus 4 whole square by 2, that is also equal to 1 by 2. Now I can complete the required matrix. Required matrix A is equal to of, sorry, yeah, first of, next what is this Nana? This is 9 by 2, okay, 9 by 2, next 0, next 2, next half, next half. Yeah, student, this is the required matrices. Okay. Yeah. Next, types of matrices. Student, type of matrix, there are several types. I will divide into two pieces. First of all, I will explain sometimes, after some operations, after that again sometimes, because to define these type of types I need operations on matrices. Yeah, first one, row matrix. Just I will row matrix, a matrix contain only one row. Okay, so I can say this is 2, 3, 4, 5, 6, this is matrix, no? Containing only one row. Columns are different, but only one row. Such matrix is called row matrix. I will write the matrix A equal to Aij m by n if m equal to 1. This is called row matrix. Okay, next column matrix. A matrix containing only one column. The matrix A equal to Aij m by n with n equal to 1 here. N equal to 1. Okay, m may be 1, that is not a big problem. N equal to 1, you can say that it is only column matrix. Okay. So, third one, important one, square matrix. Okay. A matrix is said to be square. A matrix is said to be square if number of rows equal to number of columns. If its rows, its number is important, not rows, number of rows. If number of rows are equal to number of columns, Okay. Or another words I can say that A equal to Aij m by n is square matrix if m equal to n. Number of rows should be equal to number of columns. Such matrix is called square matrix. I will write example here. Example. Only one element, square matrix only. 1, 2, 3, 4, square matrix only. Example 1, example 2. Okay. So, example 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Just like not good. I will write again. Example 3, Nana. 1, 0, minus 2, 3, sin x, 4, 7, 9, 3. Okay. This is 1 by 1. This is 2 by 2. This is 3 by 3. These are our square matrices. Okay. A matrix, in a matrix, number of rows equal to number of columns. Such matrix is called square matrix. In a matrix, number of rows are not equal to number of columns. Such matrix is called rectangular matrix. But square matrix is important for us. Okay, square matrix definition is given clearly. Okay. Note. For example, A11, A12 dot A1n, A21, A22 dot A2n dot AN1, AN2 dot ANN. What is the meaning of this, Nana? This is a n by n matrix, n by n, square matrix, n by n. I can say n by n. Okay. In a square matrix, in a square matrix, these elements, first row first column element, second row second column element, nth row nth column element are called the elements which are in principal diagonal of a square matrix. The elements, I will write the elements A11 comma A22 comma so on ANN are called elements in principal diagonal. The elements A1 are called elements in principal diagonal of a square matrix. Sometimes we need to identify principal diagonal elements. We need to identify, because based on these elements only further definitions, diagonal matrix, scalar matrix, unit matrix, so on. Okay. So, in other words, I can say that the elements of, elements of, I will write capital A, equal to Aij m by n, n by n. What type of element? A11, Aij, where I equal to j are called elements principal diagonal of a square matrix. Okay. So, these are important. Next, diagonal matrix. Important this one also. Diagonal matrix. Okay. A square matrix, square matrix, important, a square matrix A equal to Aij n by n is said to be diagonal matrix if each Aij equal to 0 for I not equal to j. That is all. And rest elements are non-zeros. And rest elements are non-zeros. Non-zero. Okay, I will explain on here clearly. Yeah, this is A1, for example, 3 by 3 matrix. This one A12, A13, A21, A22, A23, A31, A32, A33. Students, observe these are the elements which are in principal diagonal elements. Here I equal to j, here I equal to j, here I equal to j. What happened here? Here I is greater than j, I is greater than j. The elements which are below the principal diagonal, for those elements, your I should be greater than j. I should be greater than j. Here see, I should be lesser than j only. I should be lesser than. For these values, I should be less than j. Means, in other words, you can say that in a square matrix, the elements which are above the principal diagonal elements, they should follow the condition I less than j, and below the principal diagonal elements should follow the condition I greater than j. So, what I told here, Aij all equal to 0 for I not equal to 0, except this remaining all elements are zeros, such matrix is called diagonal matrix. One more important, this is taken as non-zero matrices. This is non-zero element, this is 7, this is 9, this is 4, like that. So this should be non-zero element, remaining elements are zeros, such matrix is called diagonal matrix. Okay. Next, scalar matrix. Next, scalar matrix. Scalar matrix is a diagonal matrix. Matrix in which principal diagonal elements are all are equal to a constant number, in which I will directly Aij equal to some constant k for I equal to j, like that you can write. A scalar matrix, diagonal matrix in which Aij equal to k, for which I equal to j, means like this 2 0 0 0 2 0 0 0 2. This is called a scalar matrix. What is the difference between diagonal matrix and scalar matrix? Here in a diagonal matrix these are need not be equal, but scalar matrix they should be equal. That means every scalar matrix is a diagonal matrix, every diagonal matrix need not become a scalar matrix. Okay, this is the definition of scalar matrix. Scalar matrix is a diagonal matrix in which Aij equal to k for I equal to j, for I equal to j. Already I mentioned a diagonal matrix, automatically remaining elements are zeros only. Okay. Next, unit matrix. Or identity matrix. Very important, very important matrix, this one. Unit matrix. Unit matrix or identity matrix. Okay, same. Unit matrix is a scalar matrix. I will write. Unit matrix is a scalar matrix. In which Aij equal to 1 for I equal to j. Students, 1. Yeah, 2, no, should be 1. Such matrix is called a unit matrix. Okay, I will write. See here, 1 0 0 0 1 0 0 0 1. What happened? First of all, this diagonal elements, diagonal matrix. After this is a scalar matrix. Now new one is unit matrix. Principal diagonal elements are all are equal and all are equal to 1 and rest elements are 0. Such matrix is called a unit matrix. Okay. Next, important. Unit matrix is denoted by I, capital I. Okay. So that is I2 means a unit matrix with 2 rows and 2 columns, this one. I3 means a unit matrix containing 3 rows, 3 columns. And so on. In means n rows and columns. This is about unit matrix. Every unit matrix is a scalar matrix. Every unit matrix is a diagonal matrix. Okay. Rectangular matrix next. Rectangular matrix. A matrix A equal to Aij m by n, in which m is not equal to n. Number of rows are not equal to number of columns. Number of rows are not equal to number of columns. Such matrix is called rectangular matrix. Okay, 2, 3, 4, 5, 6, 7. This is example for rectangular matrix. So what happened now? 2 rows and 3 columns. Number of rows not equal to number of columns. Okay, so next null matrix. Or zero matrix. Okay, I will write a matrix A equal to Aij m by n, in which Aij equal to 0 for every I comma j. What is the meaning of that? All elements are zeros. All elements are zeros. Okay. And it is denoted by O. So O equal to 0, 0, 0, 0. O equal to 0, 0, 0, 0, 0, 0, like that. So these all are null matrices. Okay, students, once again, Nana. So what I did, first of all, definition. What is the meaning of matrix? A matrix is a rectangular arrangement of mn numbers having m rows and n columns. Important, students, matrix is the arrangement of numbers, but matrix alone is not a number. Take care. Matrix is the arrangement of real numbers. Arrangement of real numbers which are arranged in rows and columns. This is a matrix. Matrix is not a real number. Matrix is arrangement of real numbers. Okay. Sometimes for a square matrix there exists a unique real number. This unique real number is called determinant of that square matrix. We will discuss that later. Okay. Matrix is not a real number. Sometimes for a square matrix a unique real number represents, that representing number is called its determinant. The discussion later. But matrix means what? Arrangement of real numbers. Okay. So that's why matrix is the arrangement of real numbers. Matrix is not a real number. Okay. Yeah. Elements are functions. Okay. Those are called entries. This is the notation. Notation of a matrix. M rows and n columns. This is called order of the matrix. Order of the matrix. So this showing that that matrix contains how many rows and how many columns. You should read as m by n, not m cross n, m by n, m rows and columns. Okay. After that example problem, construct a matrix A 3 by 2 with the condition. Okay. Next, types of matrices: row matrix, column matrix, square matrix, important matrix. Nana. So principal elements in principal diagonal of a square matrix important. A11, A22, so Aij where I equal to j are called elements in principal diagonal of a square matrix. Okay. After the diagonal matrix. Okay. In a square matrix, principal diagonal elements are all are non-zeros, remaining are all zeros. Such matrix is called diagonal matrix. Scalar matrix. A diagonal matrix is said to be a scalar matrix if these diagonal elements are all are a constant k, all are equal to a constant k. A unit matrix important, that constant equal to 1. Okay. For every, should write down, for every I equal to j. Important is unit matrix denoted by I, I2, I3, so on. Rectangular matrix, just number of rows and not equal number of columns. Null matrix or zero matrix means all the elements, all entries are zeros only in that matrix. Such matrix is called null matrix. Yes, students. Next type, upper triangular and lower triangular matrix. I will write upper and lower triangular matrix. Okay, first of all, for example, A is this for only for square matrix. Upper triangular, lower triangular matrix is a square matrix. For example, A11, A12, A13, A21, A22, A23, A31, A32, a 3 by 3 square matrix. Okay. These elements are said to be elements which are in principal diagonal. Okay. For these elements, what the condition? Your I should be lesser than j. For these elements, what the condition? I should be greater than j. Now I want to define a upper triangular matrix. A matrix A is said to be upper triangular matrix. If observe student, A I j equal to 0 for I greater than j. Okay. So, what is the meaning of that? These elements A21, A31, these elements, the elements which are below the principal diagonal elements are zeros, and the elements which are above the principal diagonal elements are non-zeros. Such matrix is called upper triangular matrix. I will write example here. 2, 3, 4, 0, 7, 9, 0, 0, 4. Just like this is one of the example of upper triangular matrix. Upper triangular matrix. Upper triangular matrix. Okay, triangle will form here. Upper triangular matrix. These are non-zero numbers. Upper triangular matrix. Similarly, you can define a lower triangular matrix. A is said to be lower triangular matrix. If Aij equal to 0 for every I lesser than j, I less than j. What is the meaning of here? Remaining element should be non-zeros. That is the meaning. Matrix is given on 3 entries. I will take 3 entries. 3 by 3 matrix. What is the meaning of that here? These should be zeros. This should be zeros. Remaining are non-zero number 2, 3, 7, minus 2, 4, 6 like that. So, such type of matrix is called, this is lower. Lower means upper elements are zeros. Upper means lower elements are zeros. Like that you can remember. Next, trace of a matrix. Next, trace of a square matrix. Yeah, students, trace is defined only for square matrix. Okay. Yeah, A is a square matrix. With order n by n, or the order n you can write simply, n instead of n by n you can write n also. Square, no, order n by n with n. Then trace of A defined as sigma of Aij, okay, where I equal to j. Sum of the elements in principal diagonal elements are called trace of that matrix. That is the meaning. Or I can write I comma j are 1 to n. So, sum of the elements in principal diagonal elements are called trace of that matrix. Okay. So, example I will write. A equal to 2, 3, 4, 5 given. Then trace of its matrix, TRA I can say, trace of that matrix is 7 only. Example, A equal to 1, 0, 2, 3, 1, 4, 5, 1, 6 given. Trace I want from trace of that matrix, sum of the elements in principal diagonal 1 plus 1 plus 6, that is equal to 8. Note, what is the note? Trace of identity matrix of order n equal to n only. What is the meaning of that? 1 0 0 1. What is the addition? 1 only, no, second order 2 only. 1 0 0 0 1 0 0 0 1. This is 3 by 3 unity matrix. What is the trace? 1 plus 1 3 only. That's what I wrote here. Trace of in equal to n. What is n here? N is natural number. Trace of identity matrix equal to n. Like there have several properties. We will discuss later the properties of trace of the matrix. Okay, Nana? Okay, students. Next one is transpose of a matrix. Transpose of a matrix. Yeah, if Aij m by n is a matrix, the matrix obtained by interchanging the rows and columns of A. So just for example, I will explain through example. 1, 2, 3, 4, 5, 6, a matrix. How many rows are there? 3 rows and 2 columns. If these rows are converted into columns, you get a new matrix. This new matrix is called transpose of the given matrix. This is what, Nana? This becomes 1, 2, this is 3, 4, this is 5, 6. This new matrix. But the order of this new matrix, Nana, 2 by 3. So this is 3 by 2, this is 2 by 3. What happened? Columns are converted to rows, or rows are converted to columns. This matrix is A, then this matrix is called transpose of this matrix and denoted by A dash or A power T. Understood? So what is given the definition? A equal to Aij with m orders, m rows and columns is a matrix. Then the matrix obtained by interchanging the rows and columns of A. Okay. Alright. And it is denoted by. And it is denoted by A power or A power T. Okay. Understood? What is the meaning of this? A equal to Aij with m rows and n columns, then A transpose, nothing but Ji with n rows and m columns. Okay, example. A equal to 1, 2, 3, 0, minus 1, 4 even. Yeah, what is the Nana? This is 2 by 3. Then A transpose I want. Just to these 2 rows should be converted to columns. 1, 2, 3, 0, minus 1, 4. This new matrix is called a transpose. What is important note, Nana? Important note, important note, important note. What is important note? A transpose, old transpose what? Again you will get A only. Again find transpose of this, you will get A only. That's why A transpose, whole transpose equal to A. Some more properties are there for transpose. Later I will explain, because we need to complete some more operations on matrices. Okay. Here you can say that A transpose, whole transpose equal to A. Next, equality of two matrices. Equality of two matrices. This is also very important. Equality of two matrices. Okay, when these two matrices are said to be equal, that is important. When two matrices are said to be equal. Okay, two matrices A, Aij and B, Bij are said to be equal if they are of the same order. This is very important. They should have the same order. First of all, they should have the same order. And each element of A is equal to corresponding elements of B for all I and J. Just equality of two sets, no? That like equality of two matrices. 1, 2, 3, 4 given. Equal to 2, 3, 3, 4. Okay, whatever it may be. So now you can say that these two are equal matrices, because order should be same, 2 by 2. And each, these 2 should be equal to this 2. This is what, Nana? This is actually first row, second column. First row, second column is 3 means that should be equal to 3. For example, with just I will write minus, no problem. So this 3 equal to this 3. This minus 3 equal to minus 3. 4 equal to 4. Such a way that their matrices are defined, then only they are said to be equal matrices. Okay, once again I want read Nana. Equality of two matrices. Two matrices A and B are said to be equal. They should have the same order. First condition. Second condition, each element of A is equal to corresponding element of B. Okay. For example, 1 to x 1 given Nana. So equal to 1 to some 7 1 given. What the x value means? You should say x equals 7 only. Okay. Yeah, students, here one example problem. I can say example 1. Two matrices are given equal. Equality symbol is there. Two matrices are equal. Now then find the values of x, y, z and a, b, c. Yeah, find x comma y comma z and a comma b comma c. Just comparison, no? By the definition of equality of two matrices, this x minus 3 equal to 0 only, x plus 3 equal to 0 only. Means what is the value of x, Nana? Minus 3. So z plus 4 should be equal to 6. Z plus 4 equal to 6. The meaning of that, z equal to 2. So y 2y minus 7 equal to 3y minus 2. Interesting. 2y minus 7 equal to 3y minus 2. Yeah, minus 7 plus 2 equal to y equal to minus 5. Okay. So minus 6 equal to minus 6. Okay. A minus 1 equal to minus 3. A minus 1 equal to minus 3. A equal to minus 2. A equal to minus 2. 0 equal to 2c plus 2. Na? 0 should be equal to 2c plus 2. What is the meaning of 2c equal to minus 2? C equal to minus 1. Okay. B minus 3 should be equal to this. To find B value. 2b plus 4 should be equal to b minus 3. B equal to minus 7. The value of B equal to minus 7. Next minus 21 minus 20, 0 equal to 0. So all you got now A, B, C, D, A, B, C and X, Y, Z. So this is the one of the application of equality of two matrices.